Hello calculus, welcome back. So in this video I'm going to talk to you about the derivative of the exponential function. So the exponential function is e to the x. That is our exponential function. Ooh, so pretty. This isn't a really important function in mathematics, and if this were a normal semester I would prove this for you, but it's not a normal semester, so I'm just going to show you how it is. So if we have a function, sometimes they use this big E notation. They say e of x is equal to e raised to the x power, and I take the derivative of that function. Guess what? It stays exactly the same, e to the x. Cool, right? It is very cool. And if you're interested, you can read through the proof that they give you, but I'm just going to leave it like this for now. So let's do some examples. I'm going to do first a couple examples of this, and then I'm going to let you guys loose. So let's try this. Let's say I have f of x is equal to e to the 2x, and I want to find f prime of x. So this is a chain rule problem, right? I have one function, e to the something, and then inside of that function I have 2x. So the first thing I do is I take the derivative of my outside function, which is e to the 2x. So the derivative of e to the x is just e to the x. It stays exactly the same. So then my derivative is just e to the 2x. And then I multiply that by the derivative of the inside function here, which is 2. So I get 2e to the 2x. That's our first example. Let's do another one. Let's do another chain rule that's a little more complicated. Say I have g of x is equal to e to the tangent of 2x. So this one is going to require us to use the chain rule again. So if I take g prime of x, the exponential is my outside function, and it stays exactly the same. So I have e raised to the tangent of 2x. Now I want to take the derivative of this inside function and multiply it, and I want to multiply by the tangent of 2x. And I want that derivative. Okay? So next we have to take the derivative of the tangent of 2x. So this stays the same. And now I'm taking the derivative of this in here. So the derivative of tangent is secant squared. So I have secant squared 2x. And then I actually have another chain rule in here because of this 2x inside is a function. So times the derivative of 2x, which is 2. So cleaning this up a little bit, I get 2 times e to the tangent of 2x times secant squared of 2x, and that would be my derivative. Here is checkpoint 350. So they give you this function, h of x is equal to xe to the 2x. This comes up a lot in calculus. So we want to find the derivative. So we're going to use a bunch of different rules here because I see I have the product of x and e to the 2x, and I see that I'm going to have a chain rule situation here. So we're going to have to use caution as we go. So h prime of x, first I'm going to apply the product rule. So that's going to give me, let's go ahead and highlight. Let's call, highlight. So we have this blue function, and we have this green function. So the product rule tells me I'm going to take the derivative of the blue, which gives me just 1, and multiply by the green. And I'm going to add to that the blue function times the derivative of the green function. And that's where we're going to actually use our chain rule. So let's go ahead and put that in parentheses so that we can use our chain rule there. So the derivative of the outside of the exponential function is just e to the 2x. And then the derivative of this part of the function is 2. And that's what we get. So then let's clean this up a little bit. So we have h prime of x is equal to e to the 2x plus 2x e to the 2.